Hey guys, Coach Cook again with another video to help you out. This is just about reading graduated cylinders. I've got this very nice graduated cylinder right here, okay, and it's full of a little bit of H2O, and we're just going to go over a little bit of how to read this sucker right now. So right now, if I'm holding it on a flat surface, okay, it's 40, okay, it's 40 right there, okay. 40 what though? Units are important, right? So 40 milliliters, okay. Now, if we're looking at a graduated cylinder, this is my very crude drawing. Please forgive me. Okay, I'm not an art teacher. Okay, let's say that we have the graduated cylinder here, okay? And we have our units, so 10, 20, 30, 40, okay? So 40 is up here, 10, you guys get it, 10, 20, 30, 40, okay? But remember, the way we read a graduated cylinder is to read it at the meniscus, okay, or the bottom dip of the water. So if our water line is here and it's dipping down, we're reading it at the very bottom right there, okay? So that's the number we would use. So even though this water line might start up here, which might be like 41 or 42, we don't read it as 41, we read it as 40 because that's where it is in line with the number on our graduated cylinder, okay? So that's the first thing I got to go over. Second thing is, what do we do when we have an irregular solid? And this is the water displacement, right? So you're going to have to do your math problems with them, but also just how do we find it in real life, okay? Real actual stuff, right? So if I move this down, you guys can kind of see that I have my water line at 40. Okay, actually I need to hold it up a little bit. Sorry, we have our water line at 40. And then I'll take a regular solid. So got one right here. Okay, got my zinc. And I'm going to put it in here very at an angle. That way I don't break the glass, right? Coach Cook has definitely done that one. So drop it in. And you see that now the water line has risen. It's gone from 40 to maybe like 41 or 42. And I'll only be able to read it truly if I go down and put it on a flat surface. So I put it on my flat surface, I get eye level, right? Okay, I check in here, and I see that it's actually, the meniscus says that it has gone up a whole entire one, okay? A whole entire milliliter. So once again, my crude drawing, right? On this graduated cylinder at the beginning, I had it right here, boom, 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 10, 20, 30, 40, right? The line was here, the meniscus was there, so it was at 40, my water line. Now it's gone 1 milliliter up. So that would be 10, right? Here, I'll mark that so you guys can see. Here's the bottom, like that picture. 10, 20, 30, 40, right? And then it's gone up one more, so this would be 41. Our water line is sitting right here, so I actually need to make this a little longer. And it's at the bottom of the meniscus right there. So now here's the question. How do I tell now in these graduated cylinders what the volume is? So remember, we do the water displacement, which is the difference, the subtraction of those two numbers. So if this was like a problem where I need to know the volume and I don't know it yet, okay? Let me write this up here, sorry. If I need to know the volume of something and I don't know it, I'm going to have to do a little bit of math, but it's easy, subtraction, right? So I would have to do the initial, where the water line started. So VI, initial, volume initial, and then here, the final volume, or VF, okay? So it would be, what, 41, okay? So the final water line minus the initial water line, which is I, and that would be 1. So 1 what, though? Units matter. It would be 1 milliliter, okay? 1 milliliter would be my final answer. So that's just a little bit of how to read graduated cylinders and kind of water displacement of irregular solids. So hopefully that helps.